Okay, so here's an explanation of one-tail and two-tail critical values. Now I have the normal calculator up here. I just got that from Stat Calculators Normal. And so I'm here with the normal calculator. The t-distribution calculator works pretty much exactly the same way. You just have to specify degrees of freedom. But the instructions I'm giving you here should apply for both. It's I think similar for chi-square as well. I don't think there's anything strange about the chi-square distribution other than degrees of freedom that you should need to specify. Now, when you're doing when you're calculating critical values, alpha would go in this dialog box here, or in this field here, where we have the equals. This represents, of course, the area under the curve, or the probability. So in a one-tail critical value, whatever alpha is, you just put alpha in this box, and then of course you would specify right tail, left tail, etc. So if I'm doing a right tail critical value, get my greater than or equal to, and I put my alpha value in this box, either 0.05, 0.1, etc. And then if I'm doing a left tail, I would simply use less than or equal to, and again specify alpha here, like 0.01, something like that. And I get my critical value. If I want to do a two-tail critical value, what I need to recognize is that alpha is the combined area of both tails. So there are two ways to do this. If you use the standard calculator, it only allows you to calculate for one tail, which means you do need to divide alpha in half. So for example, if alpha was 0.05, what you would need to do for a two-tail critical value is divide 0.05 in half, giving you 0.025. So for a two-tail critical value with alpha equals 0.05, you would put in 0.025. What that does is it gives you a critical value for the left tail. Because of the symmetry, you would just use the positive and negative of this same value, which would be negative 1.96 and positive 1.96. So you would have you would use the symmetry to fill in for the other side. You can also do this using the between calculator. If you do that, then what you can do is, let's say for alpha equals 0.1, you would just put in the complement, which would be 0.9, because what this is doing is it's calculating using the center area. And so the tail area versus the middle area, if you put in the middle area of 0.9, that leaves you a tail area equivalent to alpha of 0.1. If you put in a center area of, for example, 0.99, that gives you the equivalent critical values for an alpha of 0.01. So when you're using between, instead of using half of alpha, you would actually use the complement as the value that you type in, but then these values would represent these boundaries here, these critical values. So I hope that helps. I hope that gives you the information you want. Like I said, the other distribution should work the same way as long as you type in the correct parameters, like the degrees of freedom.